Hey guys, I'm Bennett Alterman, and this is my test number 2 wrapper, solving for problem number 1, the gravitational orbit of 4 objects of the same mass.
Hey guys, today I'm going to talk about test number 2, problem number 1. So, looking at the system here, we can see that we have 4 masses, each of an equivalent mass, all orbiting in a circular orbit with a distance r from the center of the orbit. So what I've done is I've set up a coordinate system where this origin is at 0, 0, and then we've set up the respective positions with r vectors for each of the 4 masses. So calculating the magnitude of this, what we did is we took m2, m1 to be negative r comma negative r. So then finding the magnitude of that, we do the same thing that we normally do, where we take the square root of both of the values squared. And this gives us a d of the square root of 2r squared, meaning d squared equals 2r squared. So, looking here, we know that F perpendicular has to be equal to mv squared over r. Because we know that the forces in this circular motion are all going to have a net effect towards the center of the circle for this rotational motion. So, moving on, we know that the sum of the force of object 1 acting on object 2 plus object 1 acting on object 3 and object 1 acting on object 4 has to be equal to this centripetal acceleration, or mv squared over r. So, solving for these forces, we use our normal force equation of negative g mm over r squared in the r direction, substituting in the appropriate masses m1 and 2, m1 and 3, and also m1 and 4. And then this gives us these corresponding values here once we plug in for our coordinate system that we created. So we have negative g m squared over 2r squared, negative root 2 over 2, comma negative root 2 over 2. For force of object 1 on 2, negative gm squared over 4r squared, negative 1, 0 for object 1 on object 3, and finally negative gm squared over 2r squared, negative root 2 over 2, comma root 2 over 2 for object 1 on object 4. So, going back to this principle, summing the 3 of these values together gives us this: negative g mm over 2r squared, negative 4 root 2 over 2, minus 1, comma 0. So, from there, we know that the sum of those forces, which is the value we just calculated, is equal to mv squared over r, or F perpendicular, which is the force pointing towards the center of the system, towards the origin. So, going from this step, we can solve for v, and we end up with negative gm over 2r times negative root 2 over 2 minus 1 over 2. Now, to find the period, we use this period equation of t equals 2 pi r over velocity, and so what we're going to do is implement this velocity right there. So now, solving for t, we find that it's equal to 2 pi r over gm times root 2 times 2 root 2 plus 1 over 4r.
So again, what we found is for the magnitude of the distance, or r, between mass 1 and mass 2, as well as mass 1 and mass 4, it's 2r squared. But notice that between mass 1 and mass 3, it's 4r squared, because it is double the distance as it is on complete opposite sides of the circular orbit comparatively as the other ones, which are on 90 degrees. We also found the velocity to be equal to negative gm over 2r times negative 2 root 2 minus 1 over 2, and we found a period of 2 pi r over gm 2 root 2 plus 1 over 4r. Thanks for watching.